All right, here we have a 10.0 liter container of gas at STP. It's pressurized to 1535 millimeters of mercury and 273 K. So I got to analyze what these things are. Now I'm noticing that I'm starting out at a pressure, STP, so I have two numbers there. Okay. I notice I want to get the volume, and I have a starting volume, two volumes. I have a starting temperature and an ending temperature. So again, two temperatures. So I have doubles of everything. Anytime you have a start and an end, then first thing you're gonna look at is either Avogadro's or the gas law triangle, okay? And since we didn't do Avogadro's for year one, the only thing we have is gas law triangle. So I know I have to figure out what my knowns and unknowns are first. Okay? My volume one, my first volume is 10.0 liters. Gas at STP, standardized temperature and pressure. My standard temperature is going to be my starting temperature because it's linked. The container is at STP, and that's 0 degrees C plus 273 gives it 273 Kelvin as my starting temperature. My starting pressure is standard pressure, 101.3 kilopascals. Now it's pressurized, so it's changing the pressure to 1535 millimeters of mercury and 273 K, temperature 273 K. Oh, wait a second, these guys are the same. So temperature is actually a constant. Temperature is a constant, I know that guy's not going to be on my triangle. So I'm going to X him off. Okay, what is the new volume? So V2 equals question mark. And what units is my volume going to be? It's going to be liters. Volume has to match. Temperature has to be Kelvin. And it just matches so well, we don't even have temperature at all. So we're going to have pressures and volumes. So that's going to be Boyle's law. Pressure 1, volume 1 equals pressure 2, volume 2. So let's see how everything else is going. My volumes are both liters, so they match. I don't have to worry about my temperatures. My pressures don't match. So let me just go ahead and convert from millimeters of mercury to kilopascals. Millimeters of mercury is on the top, millimeters of mercury is on the bottom. Now, if you would have noticed that pressure 1 is an exact conversion, then yes, you could have converted everything to millimeters of mercury, and you would have saved yourself some time. But I'm going to show it the long way so you can see the process that you need for your notes and for your work if you're turning it in. 1535 times 101.3 divided by 760 going to give me 204.6, 4 sig figs, 4 sig figs, kilopascals. Okay, so now I can substitute everything into my equation. P1 V1 equals P2 V2. P1, 101.3, V1, 10.0, P2, 204.6, and V2, that's what we're solving for. 101.3 times 10 divided by 204.6 gives me 4.95 liters because my volume's in liters. 4 sig figs, 3 sig figs, 4 sig figs, so my answer is going to be in 3 sig figs.